What is going on, guys? Today we're going to learn about stacks. So this is the conceptual video about stacks. Now, if you are new to the channel, please subscribe. Or if you've watched a few and you've liked it so far, please subscribe. Appreciate it. And if you're looking for a job or internship, check out the first link in the description. I think you'll enjoy it. But with that being said, let's get right into it. So a stack is a data structure which contains a ordered set of data, sorry. And stacks provide three methods for interaction: the push, the pop, and the peek. The push adds data to the top of the stack. The pop returns and removes from the top of the stack. And the peek returns the data from the top of the stack without removing it. Now, stacks mimic a physical stack of objects. Each plate has a weight. So let's say we push in 50, we push in 60, we push in 55. Now, you see how the first thing we pushed in is now the last thing. So the first plate you add or push onto the floor is in the bottom and the top of the stack. Each weight becomes the new top of the stack. At any point, the only weight you can remove or pop is at the top. Now you can peek and read the top weight without removing it from the stack. The last plate you put down becomes the first and only and the one that you can access. This is last in, first out, or the LIFO structure. A less frequent term is first in, last out, which is philo, but we don't really use that. We just use LIFO. It's a lot easier, right? And then is there another real world example that follows the stack protocol like LIFO? Think about your web browser when you're navigating between pages. Is there a stack like going on? Hmm. So like think of like stack of books. Let's say you put on one book and then you put on the next book. Now you can only remove the top book. You can't get to the bottom book unless you remove the top book. It's kind of like that. And then stack implementation. So stacks can be implemented using linked list as the underlying data structure because it's more efficient than a list or array. Now, depending on the implementation, the top of the stack is equivalent to the head node of a linked list, and the bottom of the stack is equal to the tail of a node. A constraint that may be placed on a stack is its size. This is done to limit and quantify the resources the data structure will take up when it is full. Attempting to push stack into an already full stack will result in a stack overflow. Similarly, if you attempt to pop data from an empty stack, it will result in a stack underflow. Now, to really represent this, we have a stack here. We have 55, which is the top. We have the 60, and then the 50, which is the bottom. Now, this in linked list is equal to the data being 55, and then it has a link to node B, and then this has the data 60, it has a link to node C, and then this is the data 50, and it's linked to null because you don't have anything at the bottom there. So let's go to review what we've just learned here. So let's take a minute here. So stacks contain data nodes. They support three main operations: the push, the pop, and the peek. The implementations include a linked list or array, but linked lists are more efficient for this. They can have a limited size, and then pushing onto a full stack will uh, result in a stack overflow, and stacks process data last in, first out, or first in, last out, which is the FIFO. Next, we'll go ahead and take a quiz here for the stacks. So, okay, if I popped a value from the following stack, what value would be returned and what would be the new uh, top of the new stack look like from top to bottom. So the top value is 55, the bottom value is 50. So we will pop. So the value will be 55 and the stack will only be 60 and 50, like so. If I peeked at the following stack, what would be returned? So again, this is 55. So if you peeked, it would return 55, but nothing would get removed. So we have this one. Because peeking does not remove anything, we're just looking at it, right? In what case would stack overflow occur? Popping data from a full stack, popping data from an empty stack, pushing data into an empty stack, or pushing data into an already full stack. Because overflow means you have too much of something. So if you already have a full stack and you're trying to push more, it's going to overflow like water. If you put more water into a glass with like a full glass, it's going to overflow. In which of the following scenarios would a stack not be the ideal data structure to model the situation? A line in a grocery store using the back and forward arrows in the internet browser, dirty plates in a sink. I think a line at the grocery store would probably not be ideal because as we've learned, the queues it handles the line structure. So I think that's why. Yeah, it's first in, first out. So that's why, yeah. And then the stack is a LIFO, but this one is a FIFO, right? Okay, if the following stack was implemented using a linked list with the head node of the linked list representing the top, what would the linked list look like if a 40-pound plate was pushed onto the stack? Well, so you have top value, bottom value, and value to add. So it'll look like 40, 55, 60, 50. Yep. That's because we just push it on there. And we got 100 on the quiz. So that's gonna end it right here. Thank you so much for watching this video. Really appreciate you. Again, if you found any value, please like and subscribe, and I'll see you in the next one. Have a fantastic day or night wherever you are.